Hi everyone, welcome to my class. Our topic in this video is about conversion and calculation of number systems such as decimal, binary, octal, and hexadecimal. After watching this video, you should be able to perform conversion and calculation and understand the significance of it. Some students are asking, why do we need to know conversion and calculation of number system? Is it important? Of course yes. As we all know, decimal number system is the most common number system and the basis of how we count. However, computers use binary number system. We only recognize the numbers 1 and 0. Programmers come up with another type of number system, the octal and hexadecimal. Octal and hexadecimal are the result of simplifying the representation of characters in programming computer. The programmers needed to find a way to simplify the data represented so it will understand by the computer. That is why knowing conversion and calculation of number systems are important in both computer hardware and computer programming in order to understand how does the computer read and process the different data. Okay, let's start our topic. Let's start with decimal conversion. So in decimal conversion, we have 5 steps. First, divide the decimal number by the base or radix of the number system you want to convert to. Second, write down the remainder of the division operation. Third, repeat step 1 and 2 for each quotient you get until you cannot divide the quotient by the radix any further. Fourth, write down the remainder for each division operation in sequence from top to bottom. And last, write down the top remainder starting from right to left, then followed by next remainder until you reach the last. Okay, let's have an example. First, decimal to binary. Example, we have decimal number 51. Decimal number 51, we will convert it to binary. Step 1. Divide the decimal number by the base or radix of the number system you want to convert to. Therefore, decimal number 51, we will divide it by 2. 51 divided by 2 is equal to 25. Step 2. Write down the remainder of the division operation. 51 divided by 2 is equal to 25, remainder 1. Step 3. Repeat step 1 and 2 for each quotient you get until you cannot divide the quotient by the radix any further. So 25 divided by 2 is equal to 12, remainder 1. Next, 12 divided by 2 is equal to 6, remainder 0. Then, 6 divided by 2 is equal to 3, remainder 0. Next, 3 divided by 2 is equal to 1, remainder 1. And lastly, 1 divided by 2 is equal to 0, remainder 1. Step 4. Write down the remainder for each division operation in sequence from top to bottom. Last step. The top or first remainder should be written first in right, going to left up to the bottom last remainder. So our first remainder is 1. Writing from right to left. 1. Then the next remainder is also 1. 1. The third remainder is 0. The fourth remainder is 0. The fifth remainder is 1. The last remainder is also 1. So decimal number 51 is equal to 110011. Our next conversion is decimal to octal. Same decimal number 51. We will convert it to octal. So again, step 1, divide the decimal number by the base or radix of the number system you want to convert to. So 51 divided by 8 is equal to 6. Again, step 2, write down the remainder of the division operation. Remainder 3. Next, step 3, repeat steps 1 and 2 for each quotient you get until you cannot divide the quotient by the radix any further. So, 6 divided by 8 is equal to 0, remainder 6. So, last step, write all the remainder starting from the top to bottom, writing it to right to left. So our first remainder is 3, then our last remainder is 6. Therefore, decimal number 51 is equal to 63 octal. Our last conversion for decimal is decimal to hexadecimal. Same steps, same procedure, but different divisor. So hexadecimal has a base or radix of 16. So we will be using 16 as a divisor. Same given, decimal number 51. 51 divided by 16 is equal to 3, remainder 3. Next, 3 divided by 16 is equal to 0, remainder 3. Then write the remainder from top to bottom, starting from right to left. So our first remainder is 3. Then our last remainder is 3 also. So 51, decimal number 51 is equal to hexadecimal 33. So let's see this another example. The first column is decimal to binary, and the second column is decimal to octal, and the last column is decimal to hexadecimal. So in this example, we have decimal number 115, and our divisor is number 2 because binary has a base or radix of 2. So step 1, divide the decimal number system by the base or radix of the number system you wanted to convert to. Next, write down the remainder after the division operation. Step 3, repeat step 1 until the quotient is equals to 0. Lastly, get all the remainder from top to bottom and write it starting from right to left. So in this example, decimal number 115 is equal to binary number 110011. decimal conversion to binary, decimal conversion to octal, and decimal conversion to hexadecimal is all the same procedure or process, but they only differ in terms of divisor because the three-number system has a different base or radix. So before we proceed to another conversion, let's have some exercises. Convert the given decimal number to binary, to octal, and to hexadecimal. You can check your answer in the description below. Thanks for watching.